Hey guys, today our notes 4B.3.2 is about rate of change. It'll go on slide 23 and 24 of your digital notebook. And at the top of your paper, you can go ahead and put your title. And we're going to talk about the average rate of change. So you found rate of change before. This is, I believe, in Math 1. And we've done it also here. Rate of change, a lot of times I'll use ROC to represent rate of change. Rate of change is just your change of your y value over your change of your x value. So this little triangle means the rate of, or the change of. So the change of y over the change of x. So your f of x2 minus f of x1 over x2 minus x1. But remember, f of x1 and f of x just means y, so it's just y2 minus y1 over x2 minus x1, which we have used recently, right? That's the formula for slope. So rate of change is basically just slope. Slope, though, is like a continuous for the whole thing. The line, the slope of a line is constant. Your rate of change can vary based off of your graph, and then you find the average rate of change. So how you're going to find the rate of change if you are looking at a table of values, so table. You can have a horizontal table or a vertical table, either way, but if you have a vertical table, you're just going to have to locate your x values. So you have your x1 and x2, and then just on the other side of your x1 and x1 and x2 will just be your y1 and y2. So you're going to be given the x's. So you're given x1 and x2. Just go ahead and locate y1 and y2. And then you're just going to plug them all into this formula up here that we're going to be using today. y2 minus y1 over x2 minus x1. The next one is if you're just given points. We're going to have an example. We're just given points. So I just go ahead and label them. You just label first point. It doesn't matter which one's first and which one's second. So you just label your first point, x1 comma y1. And your second point, x2 comma y2. And you just plug them into the same formula, y2 minus y1 over x2 minus x1. If you were given a graph, there's a couple different ways, I guess, you can use your graph. But your graph might not necessarily be, a linear one, like we've found slope before. It could be quadratic, cubic, it could be anything, non-linear even. What you're going to want to do is you're going to go ahead and just identify the 2 points. They'll give you your x's. You're going to identify your 2 points. You'll just label them as x1 comma y1 and x2 comma y2. They're normally going to give you whatever x they want you to use, and then you can just use those for your points. And then the last type is if they give you an equation. So it says interval with an equation. So for this one, what they're going to do is they're going to give you an interval. An interval is written in these little brackets. So it'll be like x1 comma x2. It's not a y, it's not a point. Points are in parentheses. This is in brackets, so that means they're both x values. You're just going to go ahead and plug these values in to find y1 and y2. And then, like all of them, you're just always using this formula right here. So for all of them, no matter what, you're using this formula. We're going to go do 4 examples from our workbook. So I need you guys to grab your workbook 4B. This is on page 86, page 86. So all 4 of your examples are super crammed on the same page. On the online version, they spread out these examples. We're not doing example 1, we're just doing example 2, 3, 4, and 5. So they're really crammed in, so you just have to kind of write small. Example 2, so we're skipping example 1, says 2 school clubs are selling plants to raise money for a trip. The juggling club started off with 250 plants and had 30 left after selling them for 7 days. The mock trial club started out with 450 plants and had 50 left after selling them for 8 days. Compare the rates at which the 2 clubs are selling their plants. If 2 clubs started selling plants at the same time, which club would sell out of plants first? Explain. All right, so we have 2 of them. So we have the juggling club. They started with 250 plants and had 30 left after selling them for 7 days. So if we want to find their rate, our rate that we're going to have is going to be the number of plants over the days. So our juggling club, it said they started with 250, they have 30 left. So if they started with 250 and had 30 left, that means that they've sold 220 plants. They've been selling them for 7 days. So their rate, 220 divided by 7, get on my calculator, is 31.4 plants per day. Can you sell a decimal of a plant? No. That's why it's the average rate of change. So one day they might sell 30, the next day, 28, the next day 45, but it all evens out over the 7 days to be 31.4. So if they have sold 31.4 per day, they have 30 left, then it should take them 1 more day. So it says, like, when will the club sell out? They need 1 more day, which means that's going to be 8 days total, right? All right, then let's look at the other side, the other team. The mock trial club started with 450, had 50 left after selling them for 8 days. All right, so now we're doing the mock trial. So we're looking at number of plants they sold over the number of days. So they start with 450, they had 50 left. That means they sold 400. Over how many days? It took them 8 days. That means that they sell 400 divided by 8. That means they sell 50 plants per day. Well, they've been selling for 8 days. They have 50 left. They sell 50 per day, so it should take them 1 more day, hopefully. That means it's going to take them 8 days plus 1 more, so it's going to take them 9 days total. So the question says compare the rates of change. So when we compare them, usually we're looking at what's bigger, what's smaller, are they both positive, negative, or whatnot. So the juggling sells 31.4 per day. Mock trial says 50 per day. So who sells more per day? Mock trial. Mock trial sells more per day. If the 2 clubs started selling plants at the same time, which club would sell out first? Explain. So the juggling club needs 8 days total to sell out. The mock trial club needs 9 days total to sell out. So that means that the juggling club will sell out first. So mock trial sells more plants per day. It's 50 versus 31.4. But juggling will sell out first in 8 days, since they started with less. So mock trial sells more plants per day. We compared the rates, 50 versus 31.4. But the juggling club will sell it first in 8 days since they had less to start. The mock trial is going to take 9 days. Hopefully you guys can all fit that in your little area. So example 3 says find the average rate of change for the function f of x equals x cubed plus 2x squared minus x minus 2 over the restricted intervals. So they gave us intervals. These are not points. These are intervals. Determine if the rate of change over both intervals is positive, negative, 0, undefined, or constant. So a positive slope would mean you have both the numerator and denominator are positive. Negative means the numerator or denominator is positive or negative, one or the other. The 0 means you have a 0 on top. Undefined would mean you got a 0 at the bottom. Constant, if it was like a line, it would have a constant slope. Use the graph of f of x to explain how the average rate of change relates to the behavior of the graph across the whole domain. Okay, so we're going to use our intervals. We have to do it twice. They gave us 2 intervals. So for my first interval, I'm going to go ahead and I'm going to call this x1, x2. So once you have x1 and x2, what you're going to do is plug those values into this function to find y1 and y2. So we have f of x1 means I'm plugging in the number -2. So x cubed right here becomes -2 cubed plus 2 times -2 squared minus -2 minus 2. You could plug all this into a calculator, but -2 cubed, -2 times -2 times -2 is -8. Plus 2 times -2 squared. Well, -2 squared is +4, and 4 times 2 is 8. Subtracting a -2 turns +2, and then -2. So -8, +8, +2, -2, all of this is just going to cancel to be 0. So that's y1 right here. All right, now we need to find y2. So we plug in f of x2. This time I'm plugging in -1. So -1 cubed plus 2 times -1 squared minus -1 plus 2. So -1 cubed, -1 times -1 times -1 is -1. 2 times -1 squared. -1 squared is 1. 1 times 2 is 2. Subtract a -1, that's +1, and plus 2. So -1 plus 2, 1. Oh, it's a -2 right here. I made a typo. This should be a -2. And that is equal to 0, so that's y2. So when we find our slope, okay, we're going to use y2 minus y1 over x2 minus x1. So y2 and y1 are both 0, so 0 minus 0 over x2 was -1 minus x1 was -2. So we get 0 over, subtracting a negative turns to adding, 1, just means the slope is 0. All right, let's do our second one. So my second one, we have our interval, our x1, x2, and then we're going to plug them in. So f of -1 is our first one. That's x1. We've already done that one though, actually. We plugged in -1 with our x2 and we got 0. It's this one right here. I don't want to have to plug it in again or show my work. Then I'm going to plug in +1. So I get 1 cubed plus 2 times 1 squared minus 1 minus 2. 1 cubed is 1. 2 times 1 squared is just 2. Minus 1 minus 2. Again, it all cancels. I get 0. It's no fun. So this is y1. This is y2. And when I plug them into my slope formula, y2 minus y1 over x2 minus x1, I get 0 minus 0 over x1 was, or x2 was 1 minus -1. So I get 0 over 2, which is just 0. So the it says determine the rate of change over both intervals is positive, negative, or 0. The interval or the rate of change for both intervals is 0. Okay, so remember our x's. So it was -2, -1, and then -1, 1. Okay, so if we look at the graph, x cubed plus 2x squared what was it, minus x minus 2, I think. Okay, so here's the interval from -2 to -1. If you can see your graph, right, if we were along this graph, to go from this point to this point, you would go up, and then you would come back down. And so average, you go up, average that with positive, average with negative, they just cancel each other out at 0. And then for the other interval was from -1 to +1. So again, we went down, that's negative, then we go up, that's positive, and they just cancel each other out because they ended at the same exact point. The average rate of change from like here to here, this would be negative. The average rate of change from here to here would be positive. But when we go from here to here, this average rate of change was 0. All right, let's go to example number 4. It says 3 linear functions, f of x, g of x, and h of x, share a common intersection point of 1, 1. So they all share the same point of 1, 1. It's a point, so that means it's x1, y1. It's not in brackets. On a coordinate plane, the function f of x passes through the point, let's see, -2, -3. So that's going to be our x2, y2. While the function g of x passes through -2, 3, so that's a different x2, y2. And then our last one is h of x passes through 2, 3, so it's going to be our next x2, y2. They all share the same point. They all have a different second point. Which function has the greatest rate of change? What are the equations of the functions? All right, we're not going to do this last part. We just don't have time. All right, let's do, I kind of color code them. So the first one is f of x. Okay, so it includes the points 1, 1, so that was x1, y1, and the points -2, -3. So that's my x2, y2. So I'm just going to plug in my slope formula. y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. I get -4 over -3. Negative divided by negative is positive, so it's 4.3. That's the slope. All right, my next one is g of x. So all of them contain the point 1, 1, so that's your x1, y1. And then we have a second point, -2, 3. That's my x2, y2. I'm just going to plug in my slope formula. y2 minus y1 over x2 minus x1. 3 minus 1 is 2. 2 minus 1 is -3. So that's -2 thirds. Over here, I don't know why I did this. I did 4.3. It's 4 over 3. Silly. Okay, then my last one is h of x. So they all contain the point 1, 1. So that's your x1, y1. This one contains the point 2, 3. That's x2, y2. So when I plug in my slope formula, y2 minus y1 over x2 minus x1. 3 minus 1 is 2. 2 minus 1 is 1. So this one has a slope of 2. So now I have to decide which one has the greatest rate of change. 4 thirds, that's like 1.33. -2 thirds, that's -0.66, or 2. Which one is the biggest? So we're going to say h of x has the greatest rate of change. All right, ROC. All right, last one. We are going to simplify this one a little bit. It says the table gives the function values for f of x equals log x over the restricted domain. It goes from 0.001 all the way to 1,000. Those are your x's. Use the data to calculate and compare the rates of change of the intervals. We're going to do the first one they have. We're not going to do the second one or a third one. We're just going to do the first one and the last one. It says describe how the rates of change of the values of x become larger and smaller. Okay, so my first one, my interval, so that's your x values. It's not a point. These are intervals. It's x1, x2. So 0.001 is my x1 and 0.01 is my x2. So the way that you locate your y's on the tables, you just look right next to them. So here's y1, y2. So I'm going to plug in my slope formula. y2 is -2 minus y1 is -3. X2 is 0.01 minus x1 is 0.001. So on top I have -2 minus a -3 turns to adding, so I get 1 over. And then I have 0.01 minus 0.001, and that gives me 0.009, which I divide those, I get 111.1 repeating. That's my slope, my rate of change. I'm going to do my second interval, so I'm going to do 1 to 10. That's x1, x2. So x1 is 1, x2 is 10, and then my y's. So y1, y2. So I'm going to plug them in the slope formula again. So y2 minus y1 over x2 minus x1. I get 1 over 9, which is 0.1 repeating. So this was the graph for log. So I want to remind you guys what a log graph looks like. It goes like straight up and then it just kind of levels off. So the rate of change is your slope, like how steep it is, right? So the interval from 0.01 to 0.1, that would be like this piece right here. It's basically going straight up. It has a slope of 111, rise 111.1, comma, run 1. Over here, this one has a slope of 0.1, rise 1, run 9. So that was like over here from 1 to 10. That one's not as steep, right? So at the beginning, these interval, this is really steep. Over here, this one is not as steep. So the question just says, describe how the rates of change of the values of x become larger and smaller. We're just going to say as x becomes larger, the rate of change becomes smaller. All right, these notes go in on slide 23 and 24, and then your homework is just 4 problems on a little Google Doc.